Keine Ahnung. So neural networks are the models um, which have collection of artificial neurons. Artificial neurons are also called as nodes, and they are connected to form a system of layers. Input layer being the first. You have input layer, you have output layer, and there are uh, n number of hidden layers. Here, all of you try to remember that we talk about shallow network and deep network. In shallow network, you find 3, 5, um, 8, maximum 10 number of hidden layers. That's why it is known as shallow network. On the other hand, deep network has tens and hundreds of hidden layers. You even have 100, 150 hidden layers between input and output layers. That's why it is known as deep neural networks. And because the number of layers are enormous and deep, so the term deep learning was coined. So you have input layer, hidden layer. How many hidden layers are there? It depends on the architecture, the model which you are designing. Output layer also depends how many output layers, nodes in output layers are there. You can have a single node in output layer, or you can have multiple nodes in the output layer. That depends on how many classes are there in your data set. If you have 2 classes, you will have 2 nodes. If you are just predicting numeric value, you will have a regressor which has only one single node in the output layer. And then what do you do? Neural network automatically infer rules to solve a determined problem. Students, here neural networks are learning something and automatically finding and determining the values. Values of what? Okay, the question is what values neural networks learn or finds. The values that neural network learns or finds are these weight values. These weights, weight, W, here, here, here. This is connected to all the nodes in the subsequent layer. One node is connected to all the other nodes in the subsequent layer, and every connection has a weight. All right, this weight can be numbered as 1, 1. From node 1 in layer 1 to node 1 in layer 2. And then 1, 2 means from first node to second node in second layer. Like that you will have weights associated. And neural networks learn the values for these weights. That is only the training process. You perform training by providing the data set. This is your neural network model. You provide the data set, and this neural network is trained, okay, number of times, now for number of epochs. You can train for 10 epochs, 50 epochs, 100 epochs. An epoch, what is an epoch? Epoch is the completion of forward and backward pass for all the training samples for once. If there are 100 training samples in this data set, take first sample, feed it to the neural network, and then you get the output through forward pass. This is known as forward pass. Then compare the output with the actual output, send the error rate back through back propagation and gradient descent algorithm, learn the new values for the weights. So this is backward pass. Up to here, backward pass. So for one sample you have done forward pass, then backward pass, and then similarly you do for every sample till all the 100 samples are completed, both forward pass and backward pass. Then we call it as one epoch. All right, one epoch means training of all the samples. Training, which training? Forward pass plus backward pass, both for all samples. And eventually the goal is to improve the accuracy. This I can compare to the revision. Whenever you get exams, you revise. You revise for the first time. You revise for the second time. Few students revise for third time. And very few revise for fourth, and one or two students might revise for fifth time as well. So what is this? You are completing the entire syllabus once. That is revision 1, which is nothing but an epoch with respect to training of the data samples. I hope it is clear. The architecture of neural network, you see here, this figure shows 2 nodes in the input layer, 2 nodes in the output layer. Oh, sorry, hidden layer. And output layer. 1 node in the output layer. And look at how it is connected. Node 1 is connected to both the nodes, this and this connection. This type of connection is known as fully connected, and the network is called as fully connected neural network. Fully connected means a node is connected to all the other nodes in its preceding layers. The preceding layer for this node is this layer, and this node is connected to x1 as well as x2. All right. So this is a fully connected neural network. One more extremely important concept and point here is about weights. Please remember that here every connection has weight. This is 1 W super 1 sub 1 1. This is W super 1 sub 1 2. This is W super 1, means this denote the layer number. Okay, and this is 2 1 from second node in first layer to first node, and W1 2 2. This will be W2, right? This is 1 1. This is W super 2. This is 2 1. This is about weights. All right, these subsequent pages will show the individual elements of this neural network, which I already explained. This is a hidden layer, this output layer, these are the neurons, and these are the weights. Instead of giving 1 2, what they have given is W. I have given like this, W super 1 sub 1 2. Okay, they have given like W1 X1 Z1. All right, and this they have named as Z. This is also Z. This is Z1, this is Z2. All right, so from X1 to Z1, this is from X1 to Z2, X2 to Z1, X2 to Z2, Z1 to Y, Z2 to Y. And look at here, this is weights with respect to layer 2. Another important concept is bias. Every node should have a bias value. This bias value all right, if you remember the line of equation, uh, equation of a line, y is equals to mx plus c. Equation of a linear line, you have y equal to mx plus c. So like this, c is a bias. Okay, c is considered to be bias. So because we are trying to plot here using these lines, if you remember linearly separability, and we have discussed about this separation of classes, and coming up with a line, straight line. So this bias, every node, besides having connection with the nodes in the preceding layers, has bias units. Okay, so this is bias B1 to Z1 and Z2. This is bias Hello. 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 Am I audible? Hello. Okay. I'm audible. I'm hearing. All right. Here, set one, but bias can also be. Most of the neural networks learn bias values as well, apart from learning weights. Okay. Activation functions. If you recall, every node in a neural network has two operations to be performed. First operation is the operation, sum, and second operation is activation function. We covered activation functions, which are function, hyper, tangent, and there are several others. These only use addition functions in deep learning. These are two are red order, and this is the oldest. What is the use of activation function? Is used to have linear, non-linear output. If there is no function, then the output will be linear. To inculcate non-linear into the model, activation is used, and they are essential part of the neural network. Without the neural network is like a linear regression with several nodes. Integration from machine learning to kind of functionality for one single node. Whereas here you have several inputs and to introduce non-unitary activation function is used. And the second property of activation is that they must be differentiable.
Ma'am, your voice is not clear, ma'am.
Actually, what happens? There is power cut. I'm running this class on mobile data. On file. It is on Wi-Fi, but this, there is a power. There is a heavy rain happening here. It is not at all clear that we will continue. Students, go ahead. Students, shall I go ahead? Yeah. Hello, Yasin. Rachana,
Yes, ma'am.
now is it clear my voice? Okay, I will
No,
continue.
ma'am. Some disturbance is there, ma'am.
Okay, then Rachana, we will have class tomorrow.
Okay, ma'am.
Okay.
Thank you. Ma'am, timing, ma'am.
Oh, wait. Again, resume. Time tomorrow, time. I sent you the timings, no? Okay,
Yes,
I'll
ma'am.
tell.
Actually, my phone display is on, ma'am.
Okay, note down. Monday, Tuesday, 11 to 12. Wait,
Ma'am, it's
1.
not here, ma'am.
In.
Ma'am, it's not here, ma'am.
Why is it here?
No, ma'am.
Okay, Rachana, Monday, uh, 11 to 12.
Okay, ma'am.
Yasin, tell me. Monday, 11 to 12. Tuesday,
Ma'am, Tuesday?
12 to 1.
Okay, ma'am.
Wednesday, 10 to 11.
Ma'am, Wednesday?
10 o'clock.
Uh,
10 to
10 to
11.
11. Okay, ma'am.
Thursday, 11 to 12.
Okay, ma'am.
Okay, Rachana. I'll end the class because the power came and again it went off.
Okay,
Uh,
ma'am.
the disturbance will continue tomorrow.
Okay, ma'am.
Okay, bye.
Thank you, ma'am. होता है ना